After watching this video, you will never forget the central limit theorem. In this video, we're going to visualize how different weird-looking distributions turns into a normal-looking bell curve. So what does the central limit theorem actually say? It all comes down to this one sentence. We average many samples from a population, and then the means of those samples will look normal. So if x bar represents average of one sample, and we, from a population, would take many samples. And then the averages of those samples will form a bell-looking curve. The bigger the sample size is, those averages from those samples will hug the actual population average more tightly. And then this is the mathematical formula. Now let's visualize this idea using a few source distributions. Let's start from a normal distribution. So the normal distribution looks like a normal curve. This is our source data. And then we will draw samples from this distribution. Our sample size will be 30. As we draw more and more samples, the mean of those samples will start to look normal. So let's draw some samples. Start it. After 200, our sampling distribution of the mean will look like this. Let's draw more. After 515 samples, it already looks like a normal curve. Let's do more. About 1000 samples, it looks like quite normal. So this is from a normal looking distribution. Our sampling distribution of the mean is looking quite normal. Now let's do the same thing with a uniform distribution. So uniform distribution looks like this. And we're going to draw samples from this, calculate the mean, and then the distribution of the sampling mean will look normal. Let's draw some samples. Our sample size is 30. Let's change that a little bit. Let's do 40 or 38. And we will start to draw samples. And after 50, our sampling distribution of the mean looks like this. After 205, it looks like normal already. Let's draw more and more. Let's stop around 1,000, 100. And it's already looking normal. So that's a uniform distribution. Let's try another distribution called exponential distribution. It looks like this. It's exponential and it has a long tail. The process is the same. Let's make the sample size a little lower to n of 20. And then we will draw samples, calculate the mean, and then the sampling distribution of the mean will look normal. Now let's take a look at how it happens. 75 samples, it's looking like this. 175 sample, it looks like a little normal already. Now let's let it run and then stop around 1,105. It's looking normal. Now let's start this whole process with a new skewed distribution. So this is a skewed distribution. Let's run this whole process. And then after about 1,000 samples, our sampling distribution of the mean looks quite normal. Let's do a bimodal distribution. As you can see, our source distribution is bimodal. It has two humps like this. Even though it's very irregular, after we do this, the drawing and then calculating the mean, and then the sampling distribution of the mean will look normal. And then let's make the sample size around 30. And then let's draw a few, 55 samples. It looks like this. After 155, it looks like this. Let's run it for about 1,080, and it already looks quite normal. So regardless of our starting distribution, our sampling distribution of the mean looks normal in the end. Now let's summarize the central limit theorem in just 3 lines. The first one is the sample means become bell-shaped even when the raw data are not. We've just seen a few examples of that. The second point is the spread of the averages shrink based on sigma over the square root of n. This means that as the sample size becomes larger, we'll get tighter clusters around the population mean. The third point is normal tools that we use in statistics such as the z-scores, the confidence intervals, or other tests that are based on normal distributions work for averages because of the central limit theorem. Hopefully you learned a lot in this BitSize Stats visualization video. In our next video, we will visualize more concepts like this, so stay tuned. If you like this content, please subscribe and check out other similar videos.